In this project, we are going to control RGB lights of 4 fountains ampoule in a wedding hall, which are located about 20 meters far from the control room and are controlled by DMX512 protocol. Here is a short view of how to control light of a small RGB lamp locally by the computer under the DMX512 protocol. PCB design of power controller boards are done in Altium Designer software with power consumption considerations. After assembling the components and parts, some heat sinks have been used to reduce thermal losses of power MOSFETs. All boards were tested locally for performance and then were installed at the project site by me. The installation of the controller boards, launch of project, and the final performance testing were all done by me, and the result was perfect. The communication platform between the DMX controller and the controlled devices is 3-wire data cable with MAX 485 protocol. In this project, the underground wiring was already done, and I just connected them to my boards. The DMX512 protocol is a serial protocol with rate of 250 kilobits per second, which is capable of sending 256-bit control commands continuously to 512 different devices, each of which has its own address. To use this protocol, the devices must be addressed, which is done by using the dip switches embedded on the controlled devices. The main processor of my controller board is STM32, and keil compiler is used as the coding environment. The computer software sends the data related to the 3 colors, red, green and blue, the light intensity and the flashing speed for each of the lamps to a Daslight device through the USB port. And Daslight device converts data to DMX512 protocol, and then with MAX 485 protocol sends it to controller boards. After receiving the information according to DMX addressing, the controller converts the color information, intensity and brightness, as well as the flashing speed to PWM signal using power MOSFETs to set RGB colors of lamps. Here the computer software automatically changes the color of the lamps in an automatic scenario and sends data to 20 lamps. We have totally 4 controller boards in this project. One is installed in the control room and it controls several wall washers lamps that are near the control room next to stairs. A high wattage power supply is located next to each control board to supply DC voltage to power lamps. And also these wall washer lamps are controlled by the same controller board. The wall washer lamps of this part are controlled by the second controller board near them. The DMX data is translated by the controller board and determines light intensity and RGB color of the lamps. In this part, the third controller board is placed along with the high wattage power supply, which controls some of the lamps on the right side of the fountain. A few other lamps on the left side are also controlled by the fourth controller board, which is located inside a box. Here I have also done a local test to determine the connection of the lamps to this board in the box. Another view of the project in day is showed here. In this project there are 20 54 watts lamps installed, which consume a total power of 1000 watts and are controlled by 4 controller boards. PCB design considerations for power consumption have been observed. Each control board handles an average of 250 watts on its 3 RGB lines. Taking into account the voltage of 12 volts, each board can flow about 20 amperes, to supply high-power RGB lamps. It's better to put RGB lamps in water to cool them down and increase their lifespan. At the end, the secret design, programming, implementation, and installation of the project from 0 to 100 have been completely done by me, and this project is being used in a wedding car.